All right, now that we showed you how to do a full R22 system, now let's do the Superheat and Subcool on a 14A system. Now, knowing the 14A systems are completely different, they have a whole lot higher pressures than normal R22 does. So, but it all works the same. So we're going to show you how that works first. Okay, John, if you'll get the hoses hooked up. Right now he's got his high side discharge line hooked up. Now he's hooking up his low side. Have you noticed on these videos we've been hooking up both hoses, manifold gauge hoses, to the unit. And the purpose of that is you cannot read what the unit's doing without doing both ways. Let's stick it right on the top up here, John.
Okay.
Good. So we can see a little bit better. There we go.
There we go.
Yeah. All right. Now we'll be hooking up my thermometer and clamp. I want to make sure I'm off that double joint on that king valve down there, so I want to make sure you're not on the king valve. Okay, John, let's put it in and let's see what happens. Now as you watch, our gauges start to drop. And that's a good sign that lets me know the compressor's running. Because if they were staying equal across there, that would mean that the compressor's not running. Also, my temperature's dropping. And if you watch it, you'll notice that it'll bounce back and forth for a few times until after everything is equalized. That's what we're waiting on for it to do, equalize. All right, let's see what our pressures are reading on our suction side. John, what is it reading?
About 115.
Okay, 115. So if you're going to convert that over, look on the chart, find the 115.
So 115 psi on 410 gives us 37 degrees.
So that's 37 degrees. 115 psig equals 37 degrees. Okay. And now our actual temperature is 64 degrees, right? 64.6. So now we're going to do 64.4. Put it in the wrong place. Well, we're just going to say 64. Make the math easier. So 7 from 14, 7. That gets to be a 5, and that makes 2. So it's 27 is what our superheat is right there. And what do we say we want it between 10 and 15? We've let our systems equal out a little bit longer. It's kind of chilly out here today, so it's taking a little longer for this to happen. So now our pressure is still at 115, and that equals 115 psig is going to equal 37, correct?
37 degrees.
37 degrees. That's what we converted it over on our pressure temperature chart. And our actual temperature is 43 degrees. So 43, always subtract your converted temperature from your actual temperature, always. No matter if it's bigger or smaller, okay? So 7 from 13 is what, 6?
6 degrees.
So now our superheat is 6. We want it between 10 and 15. This unit sitting in the shade like it is, I probably wouldn't try to put anything in it. I'd come back and check it on a warmer day. Now that we finished with the analog system, now we want to do it with the digital set of hoses and gauges, okay?
Leave that up here.
Right now he's shooting up his high side. Looking up a clamps. Now this particular gauge here, we have to change our refrigerant because we were working with R22. Now we're working with 410A. So he switched that over to 410A. Now, when you're using analog hoses, we want you to have a different set of hoses for each type of refrigerant you have. So we want to make sure that you've got the right set of hoses that you're using. You notice John's set of hoses, one had a tag for 410A on it and one had a tag for R22. If you notice a while ago, we had on our gauges, when we done the math, our Superheat Subcool was, the Superheat was 6, right? Mm-hmm. And now it's 7 over here. Now it's 6.8, so we're right on the money with each one of them. So on this particular unit here, we know we've got an issue with it. So we got 6.7 Superheat and 0.7 Subcool. So we're going to have to do some work on this one. Okay, we're going to let this equal out just a little bit longer. All right, since we know we've got an issue with the Superheat and Subcool on this particular unit here, what we're going to do, we're going to come back tomorrow and finish, do another series on this particular unit and show you what we're going to find out that's wrong with it. So stay tuned, and we thank you for attending, and I hope you enjoyed the class.